Hi everyone and welcome to the LSEG developer community. Today we're going to be looking at the LSEG data library for Python and specifically the search functionalities that you'll find in there. Now I'm going to be focusing on the contents layer, but sometimes we're going to switch to something called the discovery layer. Don't worry though, they're pretty much one and the same, so I'm going to be referring it as the access layer. If you'd like more information about all this, you can go on developers.lseg.com. In APIs, right here, you'll find the LSEG data library for Python. You'll find all this information right here. So if you're in tutorials, you'll find the other tutorials. And here, what I'm looking for right now to show you today is, if I scroll down, this link right here. Now, this is a GitHub link, and it happens to render better in Edge. So I'm just going to open it right there. So this is the link, and you'll find all of the code that I'm showing you in these videos on GitHub right there. However, the first thing I'd like to show you is this right there, this configuration file on the top left. And you can go in there and have a look at what's here. And what you can do is you can use this configuration file to authenticate yourself to the LSEG services. Now, I might have gone a bit too far already to start with. So without further ado, let's get to the code. Now, what you can do is you can have a Python environment on your own machine. That's perfectly fine, where you have your LSEG data library installed with this right here, this line pip install LSEG data. Let me try and see if I can make things a bit bigger for you. Now you can install your library right here if you want, and that will work fine. However, we happen to have on the workspace desktop application a environment for you that already has everything encapsulated, which is to say a Jupyter Lab environment that is separate from everything else, so it's secure. Where you can have some libraries that already exist in there that are already installed. So here we're going to be going on the workspace desktop application that exists, by the way, in Icon. However, we're going to focus on the newer products, the workspace one. You can go on code book right there. It will show up and it will spin this environment for you with this Jupyter Lab interface that will look exactly like this. So I'm going to navigate to a place where I've copied and pasted this notebook for you. And the difference between codebook and the notebook is this configuration file that I told you about. So here, if I was to pip install LSEG data, I can then import it as such. I'm just showing you the version very quickly here. It's 2.0. And I can either do ld.opensession to authenticate myself to the LSEG services, or use this configuration file that I've been talking about. So what I've done here is I've gone on this page that I spoke about. I copied and pasted this. So I did Control A, copy, and then I went on my machine and I pasted the information in a specific location. It can be anywhere. But I decided to put it here, and here it is. It's my LSEG data config 2. Why 2? Well, because in here I'll have a bit more information than I do in my usual one. However, I can't show you this file, unfortunately, because what I've done is, instead of where you see your key goes here and login and passwords, I've actually put in my key and my passwords as so you should. So what I've done is I've created this one right here. Actually, let me open it with Notepad, because I know that you will have Notepad and you'll be able to see it in the same way that I see it. And this is what it looks like. So here at the top, it looks something very similar to what we've got there. I copied and pasted this in here, but I added a few things. I added this search explore, full search, and searchlight right there. This will come in handy at the very end when we check the service sets that we have permissions for. Now, this is something very important I wanted to talk about at the very start. What I've done here, therefore, is I've created this JSON file that I've put in a specific location, and in my Python code, I am relating to that specific file, and I'm saying the type of session that I want to use to authenticate myself to the LSEG services. So here, it happens to be that I'm asking for the desktop.workspace one, which we can find. Where can we find it? This is platform, so that's not the correct one. If I scroll down, there you go, desktop workspace. That is the correct one. And I've put my app key in here so that I can then use the workspace desktop application running on my machine to authenticate myself to the LSEG services. I cannot use the desktop workspace session without the application running on the machine where I am running my code. However, all of this was a bit complicated. There was some cumbersome things to talk about, like the configuration file and things like this. This is not something you may want to go through, and therefore you may want to use codebook. So I showed you how you can access Codebook within Workspace. It spanned its environment right there. I created a folder on the left. As you can see, I can use this browser button to then show up the browser on the left and create some folders. Now, I suggest that you do create folders. You see, I've already a few over there. I created a few folders, one called LD for LSEG data, so lib tutorial. This is for the search tutorial. And I've pasted in my IPYMB, my notebook in there. Now you can create new ones. So here, for example, if I was to get new file, I can say a new notebook, and then you can change the extensions of IPYMB. That's one of the ways you can do it. You see, you can create your new notebooks this way. Now I've already copied and pasted everything in here, and you can make everything run right there, but it will look the same as what I'm showing you today here. So I'm going to stick with my environment where I have my JSON file, and I'm authenticating myself with my desktop workspace session. Now, everything I've just said is written here, and I will put this notebook on GitHub, so you'll have access to everything. Don't worry. And I've also put the entire JSON piece in here. So if I was to scroll down, it doesn't look very good in here, but if you have to double click, you can see it. There it is. You'll be able to go in there and copy and paste that right into your JSON file on your machine when you copy and paste it. Notice that I was able to see my table of contents with this button on the left. That's something you can find in Codebook as well. It's quite dandy to be able to just go back and forth between places in my code. Okay, as I said, I've pip installed my library, and now I've authenticated myself. Let's do this live. There's nothing like running live code in the flesh. And what we can do here then is that we can send a request to the LSEG services, and this is what we're doing right here. And today I'm going to stick with the access layer. So the access layer, which is synonymous with the discovery layer today. The access layer is in contrast to the platform session and the delivery layer, where you will be sending your requests directly to the LSEG data platform where the data is stored. You can think of it like sending a letter. In your letter, you write your request. You say, I want the close prices for the LSEG stock yesterday. You send it to that address. That address in technical name is called the endpoint. And then that server where you send that request will send you a response, and then what you have to do is unpack that response. You can think of it like opening the letter, taking the paper out of the letter, of the envelope, and reading it. You can think of that as unpacking it. But what we've done here with the access layer is that we've done all of this automatically for you. You don't have to send the requests. You don't have to know the grammar in which the request has to be sent and the one in which it is sent back. It's all done here for you, and it is unpacked into a pandas data frame. So that's what we see right here. You see I'm using the LSEG data library. I'm using the discovery module in there and the search function. And I'm going to be talking about all of these pieces here, the view, the query, the filter, all the way to the bottom here. And it's coming back with a data frame, a pandas data frame. So here there's very few data points to talk about. There's only 3 rows because I was asking for one specific thing, which is to say the exchange code. So it's giving me the exchange code for this LSEG query. But what's going on here? What have I been doing with this search function? Well, what I like to do is compare it to the search functionality here within Workspace. So if I open Workspace and go at the top here, I can type London stock. It's going to come up directly, instantly with lseg.l, which is the RIC for the London Stock Exchange Group. It's going to come up with all of these things right here. Even I think that's, what is that? It's an ordinary share. We've got plenty of things here. If you were to write option, what's going to come out? See, you've got some options coming up. These things, I like to compare it to the search API. So the search API is going to mimic what you are seeing here, and is going to return to you all of these results. You see this name right here, the RIC name right there, and even some more information. Now let's go through what it's going to return. So I sent LSEG as a query, and it's returned to me the exchange codes because that's what I was asking to be selected. However, the first variable, the first argument within our search function is quite simple. It's your query. So here, when I was showing you that example, the query is what I'm writing here in this search bar. Fair enough. And here there's another example for IBM, and you can see that it found the RIC, the identifier code for IBM, and it's found the correct one for International Business Machine Corps. That's what you expect, really, and that's your query. You can use a query with quite a few things. So here we've just put some some letters, right? IBM, that's the string that you've sent in your query. But you can do quite a few things. You can use free text like we just did. So there's an example about Chinese shipping. You can use some phrases like Hong Kong if you use inverted commas, so the double inverted commas. You can use wildcards, which are symbolized with stars. So here at the end, you've got green star, that's your wildcard, and it's a Boolean or and not. And you can have a look at it yourself. I really suggest you go into it and just play around with it really and see the results that come out. That's the best way to learn when it comes to this API. However, if you are interested in how you can create this query in more depth and detail, I suggest that you click on here, the playground reference. Now, I'm not going to click on it because it's going to log me out. It's single sign-on. So if I click on there, it logs me into the playground reference and logs me out of Workspace, so I won't be able to use the code. But in here, you'll find quite a lot more detail about the nomenclature and the grammar that you have to use in the query. And it's also the same that you have to use in, well, there's more information anyway about the one that you have to use in the filter, but let's not get ahead of ourselves. Let's stick to our agenda. Speaking of the agenda, next is the view. So the view argument is one that you can find right here. And you can think of it like a lens. So when I typed LSCG in my search bar, there was no context. It just looked for everything in the LSEG databases about that series of strings of characters. If I wrote IBM, it's going to do the same, right? It's going to give me equity, it's going to give me options, it's going to give me bonds, corporate bonds. Maybe it's going to find some strange country that has a name that may be related. But that might not be what you are after. Maybe you are only after a derivative quote. So what you can do is that you can use very specific views that are pre-made for you to narrow down your search. And here you can see we've got, I've asked for the exchange code again. So all we have is the exchange code coming out because it's just for an example's sake. But it's found some results specifically to do with the derivatives quotes. That's what we've done right here. So we've got the derivatives quotes as objects. You can see that the derivatives quote here is inside of the LSEG data library, the discovery module, the views module, and that's where that object is. However, that object is just a string. If you wanted to, you could just put the string in here. I've put it in right there. However, it is a bit difficult for you to know what the string is. Is it derivatives space quote? Is it derivatives with a small q quotes? You don't have to know these by heart, and we don't want you to learn them by heart, which is the reason why we created all of these objects. As a matter of fact, just for your convenience, I have printed all of these objects for you here, and we're gonna, we're going to run this. Yeah, let's run this because I've already run the ones before, and these are the ones that are right here. Now, why did I run it? Why didn't I just leave what was there before? Well, because this one is going to be updated. Let's say that you come into this video and you copy and paste what you see here. This might not be the latest version of the views that are available to you. However, by running this code, you can see the updated version. Now, these are the versions as a string. As you can see, you've got, there it is, derivatives quotes. And it's exactly like this, capital D, capital Q, no spaces. Fair enough, and you can use this in order to know which views to use. However, you can also use the help function, which is a native Python function help, with these views, and you will find, there you go, here they are, all of the views in question as objects. So you can see here this is views dot CDS quotes, and views here refers to, if I was to scroll back up, this here, ld.discovery.views. And you can use all of them in this way. You can see I'm scrolling down this quite a lot. Now, for your convenience, I've put them all in this cell right here. So you've got it all right here in a cell. You can go in there and copy and paste it. And what I've done right there is that I'm iterating through that list. So I've put them all in a list in order to see which views give me a result for my request. So here I have a very specific request with a query. The query is LSEG. Don't worry too much about the filter. As a matter of fact, I think you can actually remove them, but I've just left them in there to limit and narrow down my search. Otherwise, I could have 10,000 rows returned every time. I don't want that. As a matter of fact, that's what the top here is there for. So I've got my search here, and I'm allocating this result in my data frame called df, and here I'm displaying the data frame df with a little printed statement here to tell me whether or not I was able to get data for that view. So here the first view that's used is catalog item, and you can see that it did not work. There is no result for my search here for that specific view catalog items. However, there is a result for the specific view derivatives quotes, and it's given me the results right there. Now this is a little piece of code for you to use if you want, but I've just put it in there for illustrative purposes. You can look at all of the results. You see derivatives quotes and stirs works. Some of them do not. I've done exactly the same thing again, but this time not using the objects themselves. So here you see this right there, that is an object, and I'm iterating through each one of these objects above. And here below, what I've done instead is I am iterating through the strings. So here, if I was to scroll back up again, I showed you how this is an object, but if I scroll up a little bit more, I showed you how this is a string. So instead of iterating through the objects, I'm iterating through the strings, but as you can see, it's the same results. We're going to have the same results, derivatives quotes come back with the results, and the other ones didn't. That's fair enough, and it should work like a charm. We can put it all together into just having, once you've found all of the views for which you have data being returned, maybe then you'll know which one to use. Okay, so I'm interested in derivatives quotes. Derivatives quotes does indeed return some data, therefore you can use it and put it in together right there. However, if you really don't know and you don't want to go through this whole rigmarole, you can use search all. Maybe I should have started with this, but I wanted you to know about the views instead of just giving you the wildcard, the search all object that we have right here. So you can have your view search all, which does not take a lens at all. It does not think in terms of derivatives quotes or bonds or fixed income. It just goes for everything that can be returned with your query and your filter. Okay. Moving swiftly onwards, we're going to be talking about top. Now, I spoke about how I could have very many results. So here I'm doing a very simple search. It's not even that simple. I had to add a filter to filter out, to narrow down my search. And I got 10 results, but those are not all of the results that are available on the LSEG servers. Indeed, there are more, but let's say that I actually want less. Let's say that I want my code to be very snappy and quick. I don't want too much data being sent and returned. So here what I've done is I can use the top arguments inside my function to limit it. So here I've limited it to 4. The default is 10 and the maximum is 10,000. That was quite a simple one for now. However, unfortunately, now we're going to get to the meat of the business and it's going to get a bit more difficult. You may have seen above, if I was to scroll back up, that I selected a specific field. Now, we don't call them fields, we call them properties. And so that is the specific property that I have used in my select argument for my search function. But how did I know that this was a property I could use? And again, how did I know it was exchange code like this? Why wasn't there a space? Why was it not small c as opposed to a capital C? Well, I can find these things out by using the search property explorer and property type. Search property explorer really is where the use of the LSEG data library as a Python library shines, as opposed to you doing all of your own sending of requests and returning of results. So here what I've done, let's take an example for LSEG bonds. Let's say I'm interested in bonds related to LSEG, and I can use the search property explorer module, specifically the get properties for function, and I can use the exact same query I would usually use in my search function. So if I had ld.discovery.search with query LSEG bonds, I can use that same query here in this get properties for function. What I've done here is I have sent this request. As a matter of fact, let's do this live because I'd like to show you how we can manipulate this. So here I'm going to be sending my my request for the properties related to the query LSEG bonds, and I'm going to be allocating this result to a object called props for properties. By the way, just so that you know, I'm just going to call it props. And inside props, there are several objects, and I am here going to invoke the df object, so the data frame object. It's a pandas data frame, and you can see it right here. There's quite a lot of results. You can see that there are 1092 results, and here are the properties. So instead of using, if I was to go back, let's use this copy here. I'll click to the left here and then type B on my keyboard and then paste it right there. So Control V. And instead of using, what did I use before? I used exchange code. Instead of using exchange code, let's say I was instead interested in something else. So how do I know what the property is? I can look through these properties right there. Let's say instead I'm interested in this. Yeah, let's go for currency, whatever this means. So I can copy it, paste it right there, send my search, and it's going to return with only just that one specific property. And that's perfectly fine. You can find it right here, and it worked a charm. However, there are very many. I told you 1092, and that's just the ones off this specific query. You can filter it a bit more with your filter, but here you have your properties. If you want to have kind of a quick look at what the result would be like, you have your example value here, and that is where that specific function really shines. Because before we had to have a look at the property and then send that property as a request, like I've just done right here. And then only then could we have a look at an example. But here it gives you one automatically. It really is a huge time saver. So what we can do now is that we can use this and we can find the properties for that property. It's a bit difficult to understand the characteristics, I'm going to say, for that property on the right. So here we can see what the type is. So it's a string or a double. Sometimes there's a date. And also we can see if it is searchable, sortable, navigatable, or whatever. I'm going to be speaking about this in a short while. Now what I can do is I can go through my props data frame, and I can go through specifically just the properties properties column. So here, this is my properties column on the left, and I'm going to be asking for the values 1 to 6. So here, if I have a look, the properties 1 to 6 starts here, and you see we've got our, what is it, worst corp here. Worst corp shows up in my list, and you see here I'm putting it all in a list. I'm going to be using this in order to put them all inside of my search query. So you see here I have my string of properties. Notice something? I said string. I did not say list, and that's because the properties that you can put inside of the select argument in the search function have to be in a string format and not in a list format. So what I've done here is that I have, let me just do this right there. If I was to run this, you can see my list. And what I've done here is I have joined each element of my list and separated them with comma space. So now this is what this is going to look like. And here it is. We have our list of properties as a string, and I can use that and create this string right here. So that's what I've done. And we can see that it's the same string coming out right there. And then I can send this request to the servers and get only the top 15 results. So you see not the top 10, but the top 15 results for this one right there. And you see we've got all of the properties as column names at the top of our data frame. So that's all good. We can also have a very quick look at the hits. So we can have the properties hits, pretty useful. However, what if you do not see that the property that you are after in the first data frame that you see? Because you see there's 1092 elements here. That's rows here. That's quite a lot. You can filter through them, and you can do so without opening Excel or anything like that. You can use the get by name function. So here, this is a specific function that you can find inside of the props object, and I can search with this, for example. So here we were looking at bonds, right? And I'm looking for only the properties in which you can find perpetual. And here it came out. You see, we've got perpetual right here. And as you can tell already, it works with partial hits. So if I was to put this down, you see if I was to write perpet, you see I'm missing the UAL here at the end. It is still going to come out with this one property. So what I've done here is I have added this property right there, and you can see that I haven't written it correctly. You see I've put a space. I can see that my editor is shouting because I put too many spaces around the equals. But you can see here that I've put a space between is and then perpetual security. If I was to run that, it's not going to work. It's going to say, look, the property that you asked for does not exist. You have to use the one that exists in there. And that is one of the main reasons why you'd have to use this in order to find the properties that you want to use inside of your select argument. You see, it wasn't happy. So if I was to paste that in here, it's going to find the top 15 right there. And as I said, you can find the properties that you are after with partial matches, as you can find them right there. Now, you may want to only pick the ones that are searchable in order to use them in your filter. I'm going to be talking about that in a second, but I wanted to just mention it very quickly because you could use the data frame that you found. So here, this is my data frame, right? This is perpetual security. That's the data frame. And I can pick the searchable column. The values here, I'm only interested in the 0th value. So the first row, you may have many rows in yours, right? I just specifically looked for one where there was only one hit, the perpetual hit. And it says true for searchable. So this is one of the ways in which you could maybe code or encode this search for searchable properties only. And then if it's not searchable, maybe you'd want it to come up with an error of some kind that you can write yourself. Okay, moving forward, we can talk about navigatable pieces. Now, the navigatable pieces are quite interesting because they allow you to find the properties that you are after. So here, let's use the props object that we created. Don't forget, by the way, because I forgot actually, we spoke about it quite a while back. That was the props object. Let's have a look at the data frame inside of that props object. So this is what it looks like. Okay, yes, of course, we had all of our properties. Let's use the get navigatable function from that object and have a look at what comes out. And this is what comes out. This is what you just saw a second ago. We've got only the pieces that are said to be navigatable. You can see that here. It's all true. And what can you do with those? Well, first of all, you can see very easily the types that are shown in your navigatable list of properties, but you can do the same thing as well by narrowing down your search for only, let's say, Boolean pieces. So I have my navigatable data frame, and I can specify just the Boolean pieces inside of my type column. So I have my type column right there, and you can see this only coming back with Booleans because I've said I wanted Booleans right there. Whereas here, where I did not have this piece of code to filter through, we had kind of everything, strings and doubles and things as such. This is something that we've actually embedded inside of the library, so you can do it right there, ld.discovery property type Boolean, instead of doing this. You may be interested in doing this if you have quite a large data frame and some names that are a bit unwieldy, or maybe some data frames are embedded inside of other objects. In that case, you may want to use this LD discovery Boolean. Right here, we can have a look at the data frame, and we can also make sure that we pick the properties that fit the characteristics that we are after. So here we're only looking for searchable properties, and this is what come out right there outside of our props object. Okay, so what we can have a look at here is what you can use these searchable pieces for. Now I'm going to get ahead of myself a tiny bit here, but the filter is literally the next piece, I believe. The properties that are searchable, so for which the searchable here says true and not false, are the ones that you can use inside filter. I wanted to tell you this before I actually explain what filter is used for, because then we can get this through, since we're talking about the Search Property Explorer today. And if I was to run this here, I'm looking for LSEG bonds, and I am selecting this very specific property. And where is this property from? This property comes from there. I used my props and I saw that it wasn't searchable, but it doesn't matter. I can still use it in my select. Cool. Let's say, however, that I'd like to add a filter. I would like only answers. I would like only results where this specific field equals this, whatever this is. Happens to be a specific string. I'm using it for example purposes. Let's run this. So I had to press Shift Enter as opposed to just Enter. And it's not working. What's going on? There's an error going on here, and it's telling me that the property PILC is not searchable. Indeed, we saw at the top that it was not searchable. We need to pick properties that are searchable inside of our filter. But as I said, I got a bit ahead of myself here. I spoke about the filters without explaining what they are. I wanted to, before I speak about filters, quickly let you know that you could actually ask for navigatable objects directly. So here what I'm doing in this props 0 is I am asking for only navigatable pieces, and you can see that if I was to do props 0 navigators, there's nothing. There's nothing coming out. The reason for this, the reason for which dot navigators at the end of my object gives me nothing, even though there is something in my props 0 object, you can see it here. If I do .df, you can see that there is data inside of my props 0 object, is because I wrote nothing inside of my navigators variable. So if I was to scroll down, my navigators argument, you can see that I can find information about some specific properties. So here, if I'm looking for the property issue a name, I can find get possible values, for example. That's something I can use, and I can find all the possible values here with my counts. And I can do the same here with get by name. So I can look at the issuer names with the get by name, just as we did before. So here we've got issuer name through my props 0. And remember that the props 0 is something that we created similarly to the props object that we created before with the LD Discovery Search Property Explorer get properties for function. It's a bit of a long one. And what we can see here, again, by using the get by name, is the issuer name. Okay, that's brilliant. And we saw that we could find the possible values with this this function right there. That's quite useful. And we also have a count. However, let's say that I want what I'm seeing here, but not just for one property. I want to see them for multiple properties and in one go, in one time, in one data frame. You can do that with the navigator's argument right here. So let's run this. In here, I have the same props 0 definition that I created before with a very specific view. I'm calling it 1 because this time I'm adding this navigators right there. And notice that when I do props1.navigators, something comes out, and that's the thing that I was speaking about before. It's this view that I have right here, right there, but for all of the pieces that I've added inside navigators. And I can see, and it's quite powerful because I can see the counts as well, so I can see maybe the ones that are most interesting to me. The one I like to look at here, so I'm looking at LSEG bonds, right? If I was to look at issuer rating, you can see A3, and you can see there's 20 A3 ones. I don't really know what WD means, but you've got your WD and you've got 4 of them. BB plus, you've got 2, and this is a really good and powerful way you can use this to maybe mix and match data. So maybe you're only interested in knowing the ones that are both from Netherlands and also A3, and you can see how many there are right there with this count, thanks to this navigator's argument. This is something you can do similarly as I showed before without the navigator's argument if you were to only just use one navigator. So if I use one navigator, which is what I'm doing here, I'm going to get similar results to what I had before if I was to scroll back up right here. So here with my props 0, if you remember, I had no navigators, and I had something that looks like this for issuer name. And here I have something, again, very similar with my issuer country. So it's up to you. You don't have to use a navigator. If you only have one navigator, there isn't really much use, I guess, but you still can, and it will come back with interesting data, and you can find all of the information that you're after with those. But you can at least use multiple of them with the navigators. All right, we have this slight tangent about navigators. Let's get back to the meat of the subject. And for now, that is the filters. Now, we spoke about how you can have a very simple query. I often think of it like a search engine. I query something in the search engine. If I was to type London Stock Exchange on the search engine, it's going to come up with the website for LSEG. However, let's say I want to specify my search. So here what I'm doing is I'm asking for only information about LSEG.L, which is the London Stock Exchange group. And I am filtering such that I only want results where the property search all category is equal to option and the property periodicity is monthly. So what I'm saying is I only want options at a periodicity of monthly. I don't want weekly. I don't want daily. I don't even know if those are on the market. And I'd like to see this information. Now I've done .t here. Actually, let me remove .t so I can show you what it does. It's just a transpose, because otherwise I've got all of this. It takes an awful lot of vertical space on my screen. I'd rather do this .t and it does a transpose, and that's what I'm doing right here. If you see df.t, I'm using it in more than one place, but at least you can see all of the information there, and I've got all of my business entity, document title, all the way down to the RIC. Now what I can do with this is I can take the RIC that comes back from my results. For example, let's say this is what I'm after. Let's say I'm after the bid, and I can mix the information that I collected from the search function right there with other functions inside of the LSEG data library. So here, what I'm doing is I am collecting the RIC, the 0th RIC in my data frame. So if I was to do this, you can see that it's collected this RIC, which is going to be this one. So it's the 0th RIC in my response. I'm going to put this in my universe inside of my get history function, which we spoke about in another video. And I'm specifically going to ask for the field bid. Now, if you want to know which fields to ask for inside of the get history function, I would advise that you have a look at the data item browser on Workspace. You can just type data item browser and it's going to come out, and you can have a look here at the fields you have access to. But for now, I'm just going to put all of this inside of my data frame. And then what I can do is I can do df.plot. It's really that simple. Here I'm displaying the data frame so you can see it right there. And I've got a very tiny quick little graph to show the bid prices for the first result that came out of my search data frame right here, which is right there. You see, it's quite powerful. With 2 cells of code, I can first of all find an option with a periodicity monthly for a very specific RIC that I'm interested in. And then with another call, I can find the bid data and plot it. 2 cells, maybe in 3 lines you can do it. Perfect. Okay. Next is, I think, a simpler arguments that you can use inside of the search function. So here I'm using a similar query to what we had before inside of my search function, but I'm not using any boost. Now, up until now, I did not use any boost, and I have information in this that looks like this, very similar to what we had before. Let's have a look at what it would look like if I was to use boost. So here, let me run this. I can see my IDE is very unhappy about the spaces I'm putting around the equals. You can see that it still works, though it's just my IDE telling me that's not the way it's normally done. Remove those. There you go. It's not going to shout anymore. And you can see that the results are actually a tiny bit different. If I was to scroll up a bit, you can see that it's not the same results. What I've done is I have boosted to the top of my results data frame the results for which periodicity is monthly. So I did not get rid of the other results, right? I did not filter such that I only have results where periodicity is monthly. I instead boosted them at the top of my data frame in case I'm still interested in the others, right? But not to the same extent, and I'd like to just see the monthly ones at the top. And you see here I've done top 100, because when you do boosts, most of the time maybe you'll be interested in more results. Boost allows you to have a very specific item put to the top, but you can do this as well with order by. Now, order by I think is actually more powerful, because if I was to use a query like this, where there is no such order by variable, you will end up with data like this. So it's a data frame like what we are used to up until now, right here. But if I was to use order by, here I'm going to be ordering by document title. I have very different information. You see that it's ordered my results in alphabetical order by that property that I asked. It's ordering it with respect to the property document title, and it's obviously starts with A. It's in alphabetical order. However, notice that this one right here does not show up whatsoever up there. The reason is that the order is made on the LSEG server. It's not done on your side. You're not asking for information, retrieving the data frame, and then sorting it. On the contrary, you are sorting it on the LSEG servers, and then you are retrieving the data back. It's quite an awful lot more powerful. In reality, it's not as big. This is what I'm showing you right there. If I was to use my old data frame, which is called df1, and sort it, I can sort it with respect to document title, ascending equal true. You see that I do not have the same results as what we have right there. Okay, that's the order by argument. We can look at the skip argument. It's quite simple, really. I'm sure you'll understand quite quickly. Here, if I use skip 2, I have my add-in row, which is the 0th row in my returned search data frame. And when I do not use it, which is what we did for the df2, you can see that add-in is actually the second row right here. So what we've done with skip 2 is that we have very simply just skipped those two first rows. Now that's something that might be interesting, because maybe when you send your search results, you always end up with the equity for whatever if you do LSEG, it's always going to come up with LSEG.L at the first row, but you are not interested in this, therefore you might just want to skip it. That's just a very quick example if you're looking for only, let's say, options and not equity. Group by. Now you can group your results by any property that you want, and again, just like last time, we were talking about how you can only filter with properties that are said to be searchable. So if I was to go back up here, you see that it says searchable equal true, which means that I can use this property right here in my filter argument. Okay, so if it's searchable, I can use it in my filter argument. I can order by a specific property if it is sortable. So again, inside of my sort by right there, I used document title, and the reason why it worked was because if I was to see property document title here on the left, it would say a sortable true here on the right. And now we're going to be talking about the group by argument, and if I was going to use a specific property to group by, I will have to use a property where groupable here is said to be true. I can't use one that is false. With that out of the way, let's have a very quick look at what group by does. So here I have a group by that I've added here for call put option, and you can see that what's happened is that it's grouped my results from call to put, obviously call first because in alphabetical order C is before P, and it's grouped them for my results today, and it's only gone for the first 6 results. Now I can have a look at the specific properties that I can use to group from, and I can specifically pick the groupable ones in this fashion. So here, remember, I'm using the Search Properties Explorer module, the Get Properties for function right there, and I'm using the same, you see, I'm using the same filter and query here, right there, as I did right here, because I'd like to know what's going to come out in a like-for-like comparisons with respect to the properties. So here I have my properties that come back out, and I'm going to be specifically only looking for the properties that are searchable. Now I know I can use this. That's perfectly fine. Let's go for it. And this is what I've done right here, call put option. And if you were to look through there, the call put option property would be indeed groupable. Last but not least, we've got the group count argument, and this is simply just counting the number that you'd like within your group. So here, when we did our group by, we saw we had 3 calls and 3 puts. That seems to be the default. We have a default of 3 and 3, but if you wanted more, you can just do 4 and 4. So here, the group count, you've got 4 calls and 4 puts. Perfect. That's what we've got right there. Okay, I've shown you what you can do with the access layer. And as I said, I'm calling it the access layer. In truth, it's the discovery layer. I'm using those 2 names interchangeably today. However, the contents layer stays the content layer. It is still different. And what the content layer does is that it acts an awful lot more like the delivery layer, in that it sends the request that you want and it retrieves the data in a very raw format, in a Python object format that you then yourself have to unpack. And that's a technical term. We say that it unpacks these things. You can find out how to use this this contents layer with the native Python function help. So here I'm using help. I'm going inside of the contents layer. I'm looking for the search module and the definition function. So here I'm going to be defining my request, and I'm going to be getting data, and this is the data that I want to come out of it. You can see that just by looking at the documentation for it, there's quite an awful lot going on here. It's not really that simple. Matter of fact, I even put a little piece here for you to have a look at the definition arguments. So in the arguments, you have arguments extremely similar, if not exactly the same as the ones that we saw before for the access layer, and that's why I'm not going to be going through them right now with you. Do this, I think it will show up a little bit better. Okay, so if I was to use the contents layer and define my my search as just IBM, here what I'm doing is I am searching for a very specific query IBM. I am getting data from the LSEG servers, and I'm asking for the data that comes out of it. This is going to be my data 0 object. Inside of my data 0 object, I'm going to be asking for my data frame. That's what I'm doing here for my df0, and this is my df0. And you can see that it looks very similar to what we had before with the access layer, and that's what I'm doing right here. You see, I'm getting the same data or similar data with my contents layer for my different view and more specific queries. So here I'm using a query and a navigator, very much in the similar way that we did before with the access layer. But notice something. If I was to try and use the navigators in the same way that we did above, so if I have a look, where were our navigators? Here. If we try and find navigators and to find a data frame that looks like this in order to see the properties that we are interested in and the examples that can come out and the counts, that is something that you can actually find within the contents layer, but it's going to be quite a lot more difficult because this is what comes out. You see, what's going on is that the LSEG servers has sent you the Python objects inside of buckets, and it is for you to unpack. You can go ahead and unpack it inside of the contents layer, and that's perfectly fine, and it's going to give you very raw data, so it's not the same kind of data as you would find in the access layer that unpacks it for you. This is a bit more work that needs to be done. In order to find out how to use all of these navigators inside of your object, What I did is I used this help function again, and in there I saw that it said, if I was to scroll down, dict, and that stands for dictionary. So you can go in there in your navigators, have a look at the buckets and the objects that you are interested in, do .dict, that will find the dictionary, then you can find the bucket that you're after, then you can find the elements that you're after, then you have to unpack it as a dictionary again. My oh my, this is quite an awful lot of work, just in the end to have the data that you're after, which is right there. What we've done instead for you, instead of having to unpack everything in this way, is that we've created this access layer that unpacks everything quick and easy for you here today. Up until now, we spoke about our desktop session where I had to have my workspace desktop application running on the same machine where I'm running my code. And that's perfectly fine. However, what you can do is that you can ping the LSEG servers directly with your request, and they will directly send the results back to you without passing through the desktop application. That's perfectly fine. And that's not something I'd like to talk about too much today because it will complicate things even more. However, I did want to use them in order to show you how you can switch from one permission to the other if you've got several permissions, or even if you want to figure out which service set you have permissions to. Because indeed, the search API is one of the more complex ones inside of the LSEG data library. And depending on the license that you may have access to different service sets, and each service set allow you access to different views. So here, for example, if I was to scroll down quickly, just to show you, ignore this for a second, I just wanted to show you this right there. You can see the service sets views and which ones they allow you access to. So here on the left, you can see the basic view, also called the Search Explorer. And you have access to these two views, entities and catalog items. Now, if I was to go all the way back up when I spoke about views, these are the ones I'm talking about here. So if I was to go there, when I speak about the fact that you only have access to entities, what I mean is that when you have your view argument here, you can type entities. You see, that's what I mean when I talk about these views and the permissions that you have access with respect to these views. So the first one is the basic view, and you only have two views that you have access to. This is the Search Explorer service set. And the second one is the full search service set, also called the desktop service set. And you have access to, as you can see, the large majority of all the views right here. And the last one is the Searchlight. And Searchlight, you have access to these here on the right, these views. However, how do you know which one you have access to? Well, what you can do is that you can use that configuration file I spoke about in order to switch between one license and the other. Now, what I've done, as I spoke about before, is I had a very specific place on my machine where I had my configuration file. It is right there. It's configuration file 2. However, I can't show it to you because I've got my password and things like this in there. But if you have to look, if you look in here, I'm just going to open it with Notepad. You can see that it looks something like this. Now, I showed it before, but in here, what's interesting, and as a matter of fact, I actually put it there for you so that you can have access to it later. You can copy and paste this on your own config file and then populate it with your app key, your login, your passwords. And what you can see here is I've got several of them. So here I've got my specific sessions. I have set a default session to be desktop workspace. So my default one, when I just do ld.open session, is going to use my desktop workspace license, which means that I'm going to have my workspace desktop application running on the machine where I'm running my code if I'm using just this session, but I'm also specifying other sessions. Here I have my platform LDP, LSEG Data Platform session, and I have a deployed one. Now, don't worry about this one. This one is just for real-time data. And here, what I've done below is I have specified those three sessions. So I've got my Search Explore, Search Full, and Search Light sessions, and they apply for each of the service sets that I was talking to you about before. Now you can go ahead, come in here, copy and paste this, and then put in your app keys and your logins and your passwords. And what you can do then is follow me with what I'm doing in this code. So here, first, what we're going to do is that we're going to close our session. So we opened a session before, but it was a desktop session. And if you open a desktop session, as I spoke about just now, it's going to give you access to full search automatically. So you're going to have access to all of these wonderful views. However, if you use the platform session, that's what I'm doing right here, I can open my session using my configuration file yet again. So I have my configuration name, but I am going to specify the Search Explore session. Notice here that I have quite a lot of sessions. That's because I have my usual one, Search Explore, Full Search, Searchlight, and then I've got a few others that I use for testing purposes. So don't worry about too much about them. But I wanted to show you how simple it is to switch from one to the other. You see, all I have to do is comment out this one. Let's say I've got 6 of them. Is that how many I've got? I can just do this and switch from one to the other. And here we're going to use Search Explore. So let's do that actually. Let's do it live. If I was to run this and run the next codes, you're going to see the next lines of code. You're going to see that it was a bit quicker than I thought it was going to be. It's failing. Now, why is it failing? Here, what I'm doing is I'm using my Search API derivatives quotes view with the service set that I have access to via my Search Explore session. But if you have a look at the table above, you can see that with the Search Explore session, we only have access to these 2 views here. And I asked for, which one did I ask for? I asked for derivative quotes. See if I have a look here, derivatives quotes. You can see that derivatives quotes is part of the full search service set, and I do not have access to it with the Search Explorer session. Therefore, if you were to look at the bottom of the arrow, you can see that we do not have the permissions for it. It's giving you others that you have access to right there. As a matter of fact, let's have a look. Catalog item entities. What do we see here? Catalog item entities. Indeed, these are the views you have access to with the session and the license that you have. Perfect. Okay, let's go ahead with it. Then let's use entities. Let's run this, and what you'll be able to see is boom. You have everything right there. If I was to do again the same thing but with full search, so you see here what we're doing, we are first of all closing our previous session, and then we are reopening a new session with our platform full search. We can then try and find data for derivatives quotes, because if you remember, it was derivatives quotes that was in full search. But oh, what's going on here? I've got yet another error. This is something I wanted to show you. You will have to restart your kernel when using your configuration file to authenticate yourself to the platform session in this manner, if you were to switch from one to the other. So here, if I was to run these 2, you'll see that. Well, first of all, it's not happy with LD because I did not import it. So let's do import lseg data as LD. Then we can close our previous session, open a new one with a platform full search, and then we'll be able to run this with our derivatives quotes view. And then I'm going to run this as well, and you're going to see that the second one is going to fail because entities is not a view that is accessible via the full search service set. And there you go, it's failed. And at the bottom, there you go, it's showing you all of the views that you have access to. And you can do again the same thing with Searchlight. I'm not going to go through it, but I've got it here for you so that you can have a quick look. Now, how do you know which service set you have access to? Now, you could do what I've just done, test it, see what it comes back with. And if it comes back with all of these views right here, you know that you have access to the full search one. However, what I've done is I've done a tiny bit piece of code for you right here. And if you were to go in there, you can copy and paste it and use it on your end. If I was to run this right now, I believe I did not close my session. There you go. It's telling me which session I have access to right now. It's telling me full search. Fair enough. So what I've done is I've defined a function that does that for you right here. I can run this and then just run it like that. And it's going to print out the service sets that I have access to. So here I have access to this one. Perfect. What we did until now is that we used our configuration file. However, you can circumvent this and not use the configuration file at all. Now, there is one way you can do this here. I did not want to do it because I didn't want to use that specific technique, because I'll have to use my app key in here and show you my app key. But you can do this right there. You can define your session. Here, you can create a session object in Python with the LD session desktop definition function, and then you can get your session and you can set the parameters for that function. And that's what I'm doing right here. So instead of having my parameters and values defined inside of my configuration file, which you can find right there, you go. If I was to scroll down far enough, I can see my parameters, which is discovery search. Here it is. And my value, I've got them right here. you can specify them. So here I've got them here. You can specify them inside of your set param function here. However, as I said, I don't want to use this because I'll have to show you my app key. Instead, what you can do is that you can use this function right here that I found and use thanks to the help documentation finder. So here I had a look at it there, and I could see that it was using the params and values arguments. And so that's what I'm going to do right here. I'm getting my configuration file that I already have on my PC. I am setting the parameters so that I specify that I only want to have access to Searchlight, and then I can open my session. That's what I've done right there. Then you can use the function I've already defined before to find out which service set you have access to. So here that's Searchlight. And last but not least, I've done again the same thing for the full search. You can find it right here. Now, I did not run these cells because I just wanted to show you how you can do it so that you can go ahead on GitHub, find this notebook, copy and paste to your will, and use it as you see fit. Yes, search is quite a complex API, one of the largest one of the most difficult ones. And I use it most prominently when I'm trying to look for options. So I have an entire article where I look for at-the-money options through time, but I want to do it programmatically because I want it to work for any equity at all. So any option on any equity going back through time. And I can do this thanks to the search API with this library, looking for any at-the-money one looking back in time, and then I can use this in tandem with things such as get history to find data for these specific RICs for these options, thanks to the search API. So I'm sure that you'll come up with some great use cases yourself, and you'll see quite how powerful this is. And I look forward to seeing your work. All right, thanks. I'm hoping this video kind of took the fat away from this complex API and was of use to you. Brilliant. Thank you. Have a nice day.